Hello grade 10. Today we're going to start a new chapter which is water. The first part is aqueous solutions, and the objectives of our session today is to define an aqueous solution, write the equation of the solution, explain and calculate the two characteristics of a solution, and solve an application. What is a solution? Solution is a homogeneous mixture resulting from the dissolution of one or more solutes in a solvent. Solute is a chemical that dissolves in a solvent. It can be solid, liquid, or gas. Solvent, a chemical that dissolves a solute, example, water or acetone. The main solvent that we deal with is water. That's why it's called a universal solvent. And when the solvent is water, the solution is called aqueous solution. Here we have a sodium chloride solution, which is prepared by dissolving 5 grams of NaCl in 500 milliliters of H2O. In this case, the solute is NaCl, the solvent is water. The solution is called NaCl solution because when the solvent is water, the solution is named as the solute. The volume of the solution is equal to the volume of the solvent, since the addition of a solid solute will not produce a noticed increase in the volume of the solvent. So the volume of the solvent is 500 milliliters, so equals to the volume of solution 500 milliliters. Equation of dissolution or equation of dissociation. Here when the ionic compound or compounds, they dissociate into their their ions in presence of water. For example, NaCl solid, in presence of water it will dissociate into Na plus Cl minus. Here we have HCl, in presence of water it will dissociate into H plus and Cl minus, aqueous. And we have here Al2SO4 aluminium. In presence of water, it will dissociate into its ions Al3 plus SO4 2 minus, and of course it should be balanced. Okay, you should write next to the ions aqueous. Characteristics of an aqueous solution. An aqueous solution is characterized by its molar concentration C and its mass concentration Cm. What is molar concentration? Molar concentration, it expresses the number of moles of solute dissolved in 1 liter of solution. So number of moles here N, 1 liter it's volume. So number of moles, the unit is mole. The volume is liter, so it is expressed in mole per liter or mole power minus 1. It is represented by C equal number of moles of solute over the volume of solution equals to N over V. Okay? The mass concentration Cm. Mass concentration Cm, it expresses the mass of solute in 1 liter of solution. So mass here in grams, 1 liter, the unit is liter, so it is expressed in grams per liter, and it is represented by Cm equal M over V, mass of the solute over volume of the solution. But here, don't confuse between Cm and density. Density is what? Density is mass كمان over volume. But mass of what? Mass of the solute, يعني substance that you're using over كمان its volume. But here يعني mass of the substance over the mass of the over the volume of this substance. But Cm is the mass of the solute over the volume of the solution. Okay, don't confuse between them, please. Relation between C and Cm. Type. C is mass of solute over volume of solution. طيب mass of solute, how can we calculate it? هي N times what? Times the molar mass, لأنه N equal M over molar mass. So by cross multiplication you get that m equal n times molar mass over volume. So number of moles over its molar mass times volume. Type this one, number of moles over V less solution is what? Is C times molar mass. So Cn equals C times molar mass. So mass concentration equals molar concentration times the molar mass of the solute. Here we have an application. This application says we dissolve 1.52 grams of Na2SO4 in 500 milliliters of distilled water to obtain a solution S. Given in gram per mole, the molar mass of Na is 23, the molar mass of sulfur is 32, and molar mass of oxygen is 16. Calculate the molar concentration of S, deduce its mass concentration, write the equation of this solution, calculate the number of moles of Na plus and SO4 minus, and deduce their concentration. Type. So نحن what do we have? This is the solute, right? Na2SO4. This is the solute. Type. What do we have? We have M of the solute is 1.52 grams, and Villus solvent equals 500 milliliters, and we have the molar masses of these elements. Calculate the molar concentration of S. What do we know? The molar concentration is the number of moles of Na2SO4 over volume of solution. So N over V. Type. N is mass over molar mass. Mass is given 1.52. Molar mass you calculated. We have 2 Na, so 2 times 23 plus molar mass of sulfur 32 plus 4 times 16, which is the molar mass of oxygen, which equals to 142 grams per mole. So the number of moles of Na2SO4 equals 0.01 mole. Concentration 0.01 over 500 times 10 power minus 3. Why 500 times 10 power minus 3? Because the volume is in milliliter, and we know that the volume should be in liters. The SI unit of volume is milliliters. So we multiply the milliliters times 10 power minus 3, which equals to 0.02 mole per liter. So the concentration, the molar concentration of Na2SO4 is equal to 0.02 mole. Now it says the question says calculate the mass concentration. They said calculate ولا deduce? Let's see. Deduce. So So deduce, we should use Cm equals C times M, 0.02 times 142 equals to 2.84 grams per liter. If they said calculate, you just divide the mass over the volume, which is 152 over 500 times 10 power minus 3. You will get the same answer. 3.1 says write the equation of this solution. Na2SO4, in presence of water we have ions that are Na plus and SO4 minus, and you balance. Okay, you should write here aqueous and here aqueous. Okay, now calculate the number of moles of Na plus and SO4 minus. Here Na plus and SO4 minus. Again, of course, with according to SR, the number of moles of Na2SO4 minus equals to the number of moles of Na plus over 2, which equals to the number of moles of SO4 minus. So the number of moles of Na plus is 2 times the number of moles of Na2SO4, which equals to 0.02 mole, and the number of moles of SO4 minus equals to the number of moles of Na2SO4, which equals to 0.01 mole. Number 3 says calculate or deduce the concentration of these ions. So concentration here, you should know that with respect to ions, you write the concentration, you represented it by these brackets, okay? We don't write C lel Na plus, okay? This is only for ions. So concentration of Na plus equal N over V, and 0.02 over V, which is volume of solution, 500 times 10 power minus 3 equals to 0.04 mol per liter. And with respect to SO4 2 minus N over V, so 0.02 mol. Hala, we have another way of calculating the concentration of ions present in a solution if we don't have the number of moles, if only we have the concentration of the main ionic compound. Okay, so according to SR, the dissociation of Na2SO4, we will get Na plus and SO4 2 minus. When balancing, we write 2 here. According to SR, number of moles of Na2SO4 equals to the number of moles of Na plus over 2 equals to the number of moles of SO4 2 minus number of moles of SO4 2 minus. Okay, so since these species are found in the same volume, so let's divide them all by the same V. What we will get? We will get that C lel Na2SO4 equals the concentration of Na plus over 2, which equals to concentration of SO4 2 minus. So you just have to have the concentration of Na2SO4 to get these concentrations. Okay, so it's here. By this we ended our session for today. If you have any questions, please don't hesitate to ask, and goodbye.